Meet the NewMe version 2. I created it just 3 hours ago, using all the data I collected about myself over the last 5 years. This includes messages, notes, and even my chats with ChatGPT. And honestly, I was really amazed by the result. You see, training and creating your own neural network is usually a very resource-heavy process, and it might not even give any results. For example, did you know that according to unofficial data, OpenAI spent around $1 billion to train ChatGPT 5. They also used about 100,000 new generation chips, and the training took about 6 months of non-stop work. Now you can probably imagine the scale of this. But how did I, sitting at home with just one MacBook with an M4 chip, manage to create my own neural network? Well, this is what we call fine-tune a model. It means we take an already trained model and then train it again with new data. This way, we save a lot of time and money while still getting amazing results. Training itself is basically a lot of repetitive steps, each dealing with millions or even trillions of parameters. Let's take an example. Imagine a small neural network with 3 layers. Suppose we want to teach it to recognize animals by some characteristics. It's like a game. We give the model some words related to an animal, and it has to guess which animal it is. Sounds like magic, right? But actually, it's all mathematics that has been developed and improved over many years. These little circles in a diagram are called neurons. A neuron is just a small mathematical function, but together they play the biggest role in models. I'm sure you have seen a function like this. It's a simple linear function. Depending on the values of a and b, the line can change its position. One neuron is basically this function. The parameters a and b are called weights. And training a neural network is all about finding the right weights, so the output gives the answer we want. I wrote this neural network in Python using PyTorch. It's special libraries that make it easy and fast to build and train models from scratch. Now, let's get to the most interesting part, how this whole thing works. For example, we give the model 3 parameters: path size, sound, and weight. First, we need to convert all this data into numbers, into a vector. Don't worry about how this conversion works for now. When we give the data to the neurons, they calculate the results using a linear equation. After that, we get a new vector of numbers and pass it to the next layer. In that layer, similar mathematical operations happen again, and we get another vector. Finally, we pass the data to the last layer, and it gives us the final prediction vector. But the numbers in this vector don't make sense yet. That's why we use something called softmax. This function converts the numbers into probabilities. Now all the numbers are between 0 and 1, and we can classify our animal. For example, 1 mouse, 2 elephant, 3 cat. If the network gives the highest probability to the elephant, it thinks the animal is an elephant. Of course, this can be wrong at first because the model is not trained yet. That's why we need backpropagation, which is the method that helps the network learn from its mistakes and adjust the weights to improve the predictions. This is how a neural network learns from its mistakes. First, we calculate the prediction error, and then we go backwards through the network to look at the weights, adjusting them slightly in the right direction. Then we make another prediction, and at first it might still give elephant as the answer. We repeat this process over and over until the network consistently predicts the animal we want. And then I started thinking, how can I train my neural network on an M4 Air, which isn't really made for this kind of task. It doesn't have a discrete graphics card or a good cooling system. I found 2 ways to handle this situation. The simple way, just export all my messages into a table and then feed similar text to the model before it answers. This way, it would respond in my style. The more interesting way, fine-tuning, also called LoRA. Let's start with the second option. For this, I needed a local model, preferably free, that I could fine-tune. I went to Hugging Face, looked through all the models, and chose LLaMA 3 with 8 billion parameters. We'll do the fine-tuning using RunPod. This is a platform where we can run different kinds of code, including neural network training tasks. For training, I chose a package with an A40 GPU, and I'm curious to see how much it will cost in the end. As for the training data, I'll use my chats with friends and family. I exported all my message history from social networks, cleaned and filtered it, and ended up with a JSON file. In this file, the first K contains a question, the second K contains my answer. This way, the model can learn to answer exactly like me. Next, I started writing the actual code. While the fine-tuning was happening, I worked on the first option for creating my clone. This method is much easier, but a bit more expensive. That's because it's basically prompt engineering. Here's how it works. Whenever a new question comes in, I send it to the AI, and in the prompt, I include similar questions I've been asked before, along with my answers to those questions. I also add 4 sentences describing my writing style. After looking at the market and checking the prices of different APIs, I chose Gemini. For the quality to price ratio, it seemed like the perfect choice. Writing the code only took me about half an hour. Now, whenever I receive a message, my AI agent can answer in my style automatically. And honestly, I'm not surprised it works so well, because it's just prompt engineering. Nothing magical here. Okay, that's clear. But how is the training of my own model going? The full fine-tuning took me half a day. After the first test, I was pleasantly surprised. The network answered very closely to how I would, even if it was slightly worse than the prompt-based version. But that was expected, because the prompt-based method has more data fed into it, so it can perform better. On the other hand, if I had properly prepared training data with my answers, not just chats, and trained the model for 3 or 4 days, I think the results will be even better than prompt engineering. But hey, this video is not really about that. Okay, so now that we have our clone, let's connect it to our messenger so it can answer our messenger automatically. Let's do this using Telegram as an example. There are well-developed libraries for it, like Telison, which allows us to reply to private messages using the API. I read the documentation and wrote a simple piece of code that creates an auto-reply system powered by our AI. With a special flag, we can switch between different models. To make sure that neural network stays on topic, I also send the chat history from the last 10 minutes together with each request. And just like that, we get our own clone that can always reply to your messages. Now, nobody can say you are ignoring them, because technically you are responding instantly. Of course, it's not perfect, it won't fully replace your personality or charisma, but for an online story or service account, this approach is more than good enough, and it can be developed even further. Thanks for watching, see you in the next video.